The reaction of a nitrile with an alcohol in the presence of a strong acid forms an N-substituted amide. This reaction, known as the Ritter reaction, does not work with primary alcohols. Propose a mechanism for the Ritter reaction. Why does the Ritter reaction not work with primary alcohols? And how does the Ritter reaction differ from the acid-catalyzed hydrolysis of a nitrile to form an amide? Basically, Ritter reaction is the reaction between a nitrile and an alcohol to form a substituted amide. So here is the substituted amide. Now let's work on the mechanism first. The very first step that happens here is an alcohol is going to get protonated, and the leaving group from the alcohol is just going to leave, forming a carbocation. So we have this alcohol. It's going to get protonated. Okay, and it's going to get converted into a good leaving group, and it's going to leave, thereby forming a carbocation. This is the first step. And in the next step is where the nitrile is going to come into the picture. The nitrogen in the nitrile group is, with its lone pair of electrons, is going to go attack the carbocation, thereby forming a nitrilium ion. Let's draw the nitrilium ion. This is going to be a nitrilium ion where you have the positive charge on nitrogen, and this is going to be in resonance with the other resonance contributor as well. Let's also draw the other resonance contributor for this nitrilium ion, where the electrons from the triple bond is going to go on to the nitrogen, neutralizing the positive charge. Now it would be carbon's turn to have the positive charge, and the nitrogen will have a lone pair of electron on it. Okay, and in the next step, water molecule is going to act as a nucleophile, attacking the electrophilic carbon. So it goes and attacks the electrophilic carbon. And let's write down the structure here. So it's going to be N R. Okay, remember this oxygen is going to have positive charge now. Now, what would be the next step? Yes, you guessed it right. The base will go and abstracts this hydrogen, and it's going to go neutralize that positive charge. Okay, let's draw the structure. So you will be having COH and the double bond between carbon and nitrogen and an R dash. Now this product tautomerizes to give the actual N-substituted amide that would be the product for this reaction. So what happens here is the hydrogen from the oxygen is going to move on to nitrogen, and the double bond between the carbon and nitrogen is going to move between carbon and oxygen. And there we have our amide, N-substituted amide, which is a product from Ritter's reaction. Okay, which is a product. This is our product from Ritter's reaction. Now let's address the second question we have here. Why does the Ritter reaction not work with primary alcohols? Now to answer this question, we need to again go back to our mechanism. Looking at what is happening to the alcohol. The alcohol is first getting protonated, and the leaving group is going to leave, and it's going to form a carbocation. Let's consider a primary alcohol. Let's take a primary alcohol. So in the first step, it's going to get protonated, and the leaving group is going to leave, and it's going to form a carbocation. But this carbocation is not much stable compared to the tertiary carbocation or a secondary carbocation. So the Ritter reaction definitely is not going to work with primary alcohol because of the low stability of the primary carbocation. Let's also answer the third question. How does the Ritter reaction differ from the acid-catalyzed hydrolysis of a nitrile to form an amide? Okay, whether it's Ritter reaction or acid-catalyzed hydrolysis of a nitrile, both of those reactions are going to give us amide. Okay, but remember, the acid-catalyzed hydrolysis of a nitrile is first going to give an amide, but that amide is going to undergo further hydrolysis to give a carboxylic acid. Okay, so this is going to give us carboxylic acid in the final step. Now, when we look into the first steps for each one of these reactions, the electrophile is the one that's going to be different. So in the acid-catalyzed hydrolysis, what's going to happen is it is the proton that's going to get attached to the nitrogen, right? Whereas in Ritter reaction, you can see that it is the carbocation that's going to get attached to the nitrogen of the nitrile group. So here there is carbocation, whereas here it would be just H plus. That is the basic difference between these two reactions, but both of those are going to give us amide.